Good evening. I'm Charles Schultz, and this is the Randomizer for the 22nd of March, 2022. And tonight we're going to talk about something that's a little different from many of the things we talk about. This is actually a term in the biological sciences, hypha, Hypha, and it refers to the filament-like structures that are most of the body of fungus and other similar organisms. So we'll talk about hypha in just a bit and get into what they're all about and what's so remarkable about them. First of all, I'd like to just bring forward the idea that we could always use more support and more members, and to go to schultzlaboratories.com or universeciencecenter.com. Go to the pages, walk around in our 3D virtual world, our galleries, and explore some of the things we have on exhibit, and share it with your friends. Use your Oculus or your Vive or any other sort of 3D headset you have. It'll be a lot of fun. Also join us 6 p.m. every weekday Eastern Standard Time for the Randomizer, of which this is an episode, and 9 p.m. Mondays. We will be getting back on our lessons very shortly. I believe it's going to be the robotics course. That seems to be the one people really like, but we'll be getting into the math and music course directly after that. So if you also are skilled at teaching, have some sort of learning or skill or ability that you wish to teach others, share with the world, contact us and we could set you up with a gallery or teaching center or a classroom in our virtual space, allowing you to reach many people all over the world in a controllable and clean environment that allows you to display your work so that others can see them and come in when you're not teaching. So it'd be an interesting experience for you, and it would expand your ability to reach people around you and share what you know. So on to the subject matter for tonight. So hypha. A lot of people look at a mushroom and they think, oh, that's kind of cool. But what they don't realize is that most of that material they're seeing is just a little bit of the overall bulk of the organism. And quickly, we need to talk about the 5 kingdoms of life. Everybody thinks of plants and animals, but it has been found that there are literally 5 different types of organism. And so these 5 different kingdoms are, of course, the plant families, the animal family, the fungus family, which is one of the big 5, and there are also protists. Now, protists are microorganisms such as protozoans. They're fairly complex. They may or may not have chloroplasts. Some do, some don't. And included in the protists are some types of algae, specifically the ones that are mobile. They have 9 cilia or hair-like projections and 2 flagella. And those are like the little oars that they beat in the water to swim around. Those are actually protists, even though they have chloroplasts. They're not plants. And then among the 5th family are called the Monera. And the Monera are basically, they're often single-celled organisms, and it can include things such as the archaea, the very simple non-nucleus cell type animals or plants, or, well, they're not animals or plants. They're archaea. They're super simple, primitive cellular organisms, but also mixed into the Monera are bacteria, cyanobacteria, which is sometimes called blue-green algae. And understand that many types of algae are not plants at all. There are types of microbe that are not of the plant world. And a lot of it you'll discover when you start looking at the classifications of organisms comes down to definition. So, it is often stated that you see a fossil for this and a fossil for that, but there doesn't seem to be any transitional fossils going from here to there. Actually, there are. But in the case of organisms, there are many times organisms that are transitional organisms from one kingdom to the next. And so it becomes, in many cases, an argument of classification about exactly what they are. Well, fungi, as a general rule, are pretty clear-cut. There are some that appear to be on the borderline, but we're going to focus specifically on those with these specific characteristics. So you're walking the field and you see a mushroom and you decide to pick it. But what you might not recognize, when you pull it, you see what looks like roots at the bottom. Those aren't roots at all. In fact, those are hypha or hyphae, the plural. Many of us know that tissues and structures in animals and plants typically have significant differences. In an organism such as an otter or a whale or a mouse, you will find that in any of these animals there is vascular tissue, muscle tissue, skin tissue, mesenchymal tissue, all different types of tissue. There's liver tissue, and all of them have very specific characteristics. In plants, there are leafy tissues that support the chloroplasts in large areas and have stoma for breathing and exhaling moisture and oxygen. And then you have vascular tissue, which is generally a little more woody and fibrous and hollow and conducts fluids around. So there's different types of tissue in plants as well. In fungus, you will find there is often mostly a single type of tissue. And when you see that you dig into a stump or a clump of old rotted material, you find all these filaments that look like roots in there. These are hypha, and they are the main body of most fungus organisms. So what's interesting is that what you see appears to be something like a root. Understand that fungus don't live the same way plants do. They typically live off of decaying material and primary mineral materials, and sometimes biological materials from other organisms that are still alive. And that's an interesting point, which we'll get to in just a moment, about different species of mushroom. When the hyphae underground grow into a large enough mass, and they have the proper resources and the conditions in the world are right, they wish to reproduce. And the way they do it is they grow what is known as a fruiting body. And this is typical in almost all species of mushroom. When you pick a mushroom, you're picking only the fruiting body. And there's a reason for that name. And it's because that is what bears the spores of the mushroom. So the hyphae are the main body or structure of the fungus, and it lives almost always completely underground or in a stump or in some structure out of the way from your sight and protected from the environment. But now here's the interesting thing. The same type of tissue, these filaments, will grow together into a nodule, which then erupts from beneath the soil, and on the particular day when it might have rained or the conditions are just right, they blow up like overnight, and all of a sudden there's this whole blown structure, a mushroom above the ground, and it lasts 2, 3, 4 days, get larger. It is not actually undergoing growth in the way you think. What you're seeing is a whole collection of these hyphae together in a solid mass. It is a general purpose material that can change its physical structure to assume different identities in the organism of the fungus. So the main body of the hyphae are this mass underground that stays there at all times, and it gets all the resources, similar to the roots of a plant in many ways, but it's also a structure that is alive and is the main life of the organism. When the conditions are right, it erupts in nodules of hyphae that are tightly packed to make the structure of the body of the mushroom. So this is literally the same material as the clumps underground, but it's organized in a different manner. So underground, they're very root-like and spread out, but when all the fibers come together tightly packed and in parallel form, they form the structure and body of the mushroom above the soil. So this is what's most interesting. At the point where it comes out and the crown of the mushroom opens, the filaments or gills that they form underneath then break down into little structures that make the spores, the parts of the mushroom that can reproduce and are drifting off in the wind to start new hyphae colonies underground. So now many mushrooms are simple to grow, and they don't need anything specific or special in order to do it. You give them the right decaying matter and the right conditions, and off they will go. One problem: people love mushrooms. Many people are the Epicureans love specific types of fungus, and it's difficult in many cases to make them grow easily, to reproduce. And so the most expensive fungus or mushrooms in the world are those which are darn near impossible to cultivate under many circumstances. So, and the morel is one of them, and So you will see that there are many types of mushroom that are easily collected in the wild, but very difficult to farm. And why is this? Well, it happens that in many cases, mushrooms that we commonly eat, that we get in the supermarket, such as the plain white button mushrooms, or any of the larger ones, that are large enough you can stuff the whole thing, and everybody knows what I'm talking about. You've got mushrooms in the store of 2 or 3 different varieties, but the white button mushrooms are the most common in American stores. These are easy to grow, and why is that? They'll grow very easily on rotting wood or a log or wood compost. They don't need any specific conditions in order to grow. But some sorts of mushrooms, like the porcini mushrooms or porcinis, it depends on whether you're Italian or not, if you're properly pronouncing that. And the chanterelle mushrooms and the morel mushrooms are 3 very popular and rather expensive breeds. They will not just grow in anything. You see, they have an association with specific types of tree or plant, such as oak trees, for instance. And the reason is the hyphae, the bodies of filaments under the soil, break into the structure of the roots of those plants and, in a sense, infect them. And they draw off material that is not available in the soil or in decaying matter. And this is what feeds them in many cases. So in order to grow them, you actually have to find the roots of certain trees to infect and cultivate to get that specific type of fungus to grow. And this is what's driven the prices up in the market. Now, in recent times, people who study biological sciences and in particular fungal organisms have been able to find ways to cultivate these things and bring the price down a little. But understand, you're not going to have this happen overnight. It usually takes a couple of years for these new cultures to get established. But what's most interesting about hypha, in particular, the single filament, is the way that it can be reconfigured into different forms. So as you can see, the structure underground is one body, the fruiting body of the mushroom is a completely different structure, but made out of the same basic material. It's as if that tissue can morph into a different form, given a certain chemical cue in the organism. And that's exactly what's happening. It's kind of like the liquid metal terminator, but not quite as robust. The same sort of material forms a completely different structure with a different command. And in this case, a molecule is the command. And in biology, molecules typically are messages. They're switches, commands, and messages that tell an organism how to grow or how not to grow, what sorts of results to produce, what tissues to make. And this is one of the things that's really interesting about our world. Biology uses molecules as signals. And when we start seeing things that way, we understand why environmental pollution does so much damage, and medications we throw away when we're done with them can do so much damage. A lot of times, these are molecules that don't exist in the natural world, and there are very few mechanisms for breaking them down. And so they can have unintended consequences on various organisms that encounter these medicines or compounds. So this is one of the biggest threats with pollution. It isn't so much what we're putting in the air or what we're exhaling or what we're burying. It's the compounds associated with them that get into the environment and cause biological switches to be thrown inadvertently in organisms. And it can cause things like frog populations to collapse because they've got 5 legs or 3 eyeballs or something. And it literally is because these molecules act as switches to change the destinies of the tissues in those organisms. But one interesting outshoot of the fungal industry is the discovery that hypha or hyphae can be formed into structures. There are companies that grow specific forms of fungus very rapidly and in forms to act as packing material. They have an innocuous structure, they're fully biodegradable, they're easily formed, and they make like the cardboard corners you put things in when you're packing crates full of equipment. So you've seen the recycled cardboard pushed together to make egg cartons out of paper. It's a similar process, only you grow it in a form. So many sorts of fungus have now been conscripted to grow structural or packing material by placing it in a form and cultivating it there. And so there are whole industries that have sprung up around giving the proper messages, chemicals, and forms for these devices to grow into, these organisms to fill the mold and become a functional, useful piece. And again, the big thing here is these structures are fully recyclable, being made completely of organic matter. And in some cases, some of these filaments are fine enough and programmable enough, in a sense, to become coated in metals and become electrodes in batteries. Many tiny organisms can be induced to absorb tin atoms into their outer skin. And then when they are collected as a mass of fuzzy, high surface area material, they can be put in a plating bath, coated with gold, for instance, and become the electrode for a capacitor or a battery energy storage system. So we're learning a lot of tricks from fungus, and this is one of the things that actually help improve our technology in the world in general. So I guess when you come down to it, some of the most simple organisms, and in our perception, turn out actually to have a lot of function that we can take advantage of and actually help make the world a little better. So if there are any questions on the floor, I will look for those. Now is your time, and I will repeat my invitation to come to Schultz Laboratories or Universe Science Center, study our internal galleries in the virtual world, and give us some hints about what you need. If you're teaching a special class or you do homeschooling and you want to see a certain lesson, send us a contact. Join us on this randomizer show. Let us know, and we'll see what we can do to accommodate you. And finally, my quote for the day: "Nor is there salvation in any other, for there is no other name under heaven given among men by which we must be saved." And that is Acts 4:12. There's only one name that will work for you. Well, with a lack of any questions on the floor, I'm going to say this has been the Randomizer, and I hope you learned something interesting about fungal organisms and life in general. We still don't have it all pigeonholed, and there's still good arguments about what category some organisms fit in. That's the way science goes. We're learning every day. Well, I hope that you've enjoyed this talk. My name is Charles Schultz, and this is the Randomizer, and I hope you have a wonderful evening and make the world a better place. And thank you for joining me tonight, and we'll talk to you later.